Hi! Have you ever wondered how we can determine if observed data matches our expectations?
So today, we're going to be discussing the chi-squared test. Before we start, let's have an overview over what we will be covering.
Firstly, we will be defining what a chi-squared test is, then how it is used in study, and finally, solving it. So, let's start off with defining what a chi-squared test is.
The chi-squared test is a non-parametric statistical test commonly used for categorical data. It assesses whether observed frequencies significantly differ from expected frequencies. Chi-squared tests are useful in evaluating relationships among categorical variables without assuming the normal distribution.
There are three categories of chi-squared tests. 1. Goodness of fit test. Determine if a sample's distribution fits a specific distribution, often unknown as hypothesized one. 2. Test of independence evaluates whether two categorical variables are related within a single sample.
3. Test of homogeneity compares the distribution of a categorical variable across two or more populations to check if they are similar. These tests help researchers verify whether observed associations or distributions in sample data reflect true relationships in a larger population. By comparing observed frequencies with expected frequencies under a null hypothesis, chi-squared tests reveal whether deviations are statistically significant or likely due to chance. This is particularly useful in understanding relationships between variables without assuming normal distribution, enabling researchers to draw meaningful conclusions about patterns or associations that may exist across different groups or conditions.
There are 5 steps in chi-squared testing. First is define hypotheses. Second is construct a contingency table. 3 is calculate expected frequencies. 4. Compute the chi-squared statistic. And 5. Compare the critical value.
The specific part in which the chi-squared test is useful are the data analysis and the result and discussion.
In order to solve this, let us use a research question. Is there a significant relationship between students' problem-solving skills and A. Mastery of basic skills, B. Attitude towards mathematics, and C. Parental involvement? We will focus on mastery of basic skills for today's lesson. So, we created a contingency table of the data gathered. Then, the expected frequency for each cell is calculated using row total times column total over grand total. For example, the expected frequency for mastered basic skills and mastered problem-solving level is E is equals to 45 times 50 over 150 is equal to 15. After computing, put the data into a table. Then, the chi-squared statistic is calculated as x squared is equal to the summation of O minus E squared over E. For example, for the cell mastered basic skills and mastered problem-solving level, 30 minus 15 squared over 15 is equals to 225 over 15 and equal to 15. Repeat this calculation for each cell and sum the values to get the total chi-squared statistic. Then, to calculate for the degrees of freedom and critical value, degrees of freedom is calculated as df is equal to r minus 1 times c minus 1 is equal to 3 minus 1 times 3 minus 1 equal to 4. The critical value for alpha is equal to 0.05 and the degree of freedom is equal to 4 is 9.488. If the calculated chi-squared value exceeds this critical value, we reject the null hypothesis. So, to conclude it, if the computed chi-squared value, for example 52.39, is greater than the critical value of 9.488, we reject the null hypothesis, concluding that there is a significant relationship between basic skills and problem-solving ability.